Hi everyone. Thank you so much for joining me. This is Ajit Singh Rana, and let's wait for next 2 to 3 minutes while people join us. Till that time, I will just go ahead and keep my slides ready. Okay. So till the time before we start this workshop, I want you to just go to the chat window and try to introduce yourself. Where are you from and what is your name? So let's wait for a few more minutes till we start with this workshop. Give a thumbs up if you are hearing the audio in the better quality. If not, then I can tweak it at my end. But if you are able to hear my voice, give a thumbs up. Yeah, hi Sachin. I see folks joining in. Hi Aman. And I also see Ashutosh Kumar. So let's wait for a few more minutes till folks join because I know it is Saturday and you might be busy in other work. But as I said, right, this YouTube video is being streamed and it will be available for you even if in between if you miss few of the session or you're not able to catch up with all those demos. Don't worry about it because this will go public as soon as we finish this workshop. So this workshop is going to be like 2 hours workshop, and we have last 15 to 20 minutes where I can go through all those questions which you have. And yes, we will keep it very fun, very we will bring fun into the workshop itself and try to see like if we can cover all those agenda on time. Okay, so going ahead a little about myself. My name is Ajit Singh Rana. I work as a DevRel manager at Docker. It has been like 3 years I've been working in Docker. I have been part of the Docker community for almost like 10 years now, ever since Docker was just like 1 or 2 years old. I'm also founder at Collabinix. Collabinix is our community site, community portal where people come in, they contribute. We do meetups all across India, and almost every month we do meetups in Bangalore. And we have community folks who basically travel a lot, and then we ensure that we talk about all the latest and greatest which is happening in the Docker space. I'm also part of the Docker community leader. Community leaders are those individuals who take care of the life cycle of the events which happen, especially the Docker meetup events. So I've been part of that since 2017. Also as part of let me see if I can, if my slides are visible or not. Let me check quickly. Okay, I do see a couple of comments saying like there is a lag. Okay, hi Arun, hi Sandeep, thanks for joining. Let me go ahead and see whether I am able to share my screen or not quickly. I'm using StreamYard, and yeah, so my screen was not shared, but at the same time, you should be able to see it now. If you are able to see my slides, give a thumbs up. Let's wait for a few more seconds till my slides appear. Yeah. Looks good. Okay. So let's jump into kind of the Slido. So I would like you to scan this particular QR code and try to answer. So the whole idea is trying to understand you as an audience, saying like, which of the following AI ML tools have you used in the recent past? Just go ahead and try to see if you can answer that, and based on that, we will see the live results. If you haven't heard about all these terms, just go ahead and select I'm pretty new to Docker or any of these topics. So if you have heard about C Agent or Agentic Compose or MCP toolkit or runner, because we are going to cover today most of this topic. So go ahead, bring up your mobile, scan it, and let's see. Let's understand who the audience are, so that based on that, I can modify my presentation. Let's wait for next 1 minute till the time you bring up, you basically answer all those questions. So till the time, I will jump into directly into uh, the screen which shows me the live. So right now, if you see here, I'm able to see, like, most of you are pretty new to Docker, maybe like how many votes, but go ahead, participate. I can see there are around more than 50 people who have joined right now. So most of you folks right now, I can see you are pretty new to Docker. It's okay, because I have few of the slides which talks about, step by step, how to install Docker desktop, how to enable the model runner. So let's wait for next 10 minutes, and then based on that, we will proceed further. Okay. So till now, only 14 people have answered it. So I suggest all of you who have joined, scan the QR code, answer the question, especially because this is like an AIML session, right? So I do expect that people are at least aware of what this generative AI means, right? We have 16 people who have joined till now. Okay, this looks good. I have few of the idea like what to present and what not. And then jumping into the other question which we have is more like, okay, what are you expecting from this session? What are your expectation from this session? If you can just go ahead, type it down. If you want to learn about Docker or want to know more on AI ML stuff, just go ahead and put it in the form of the text. I will wait for a few more minutes. I do see participants coming in, they are typing. We'll keep it really slow. If you are already expert in kind of an AIML, you have worked in Docker, I would suggest that this is a very introductory session where we will talk about MCP, Agentic AI. Yeah, I can see someone responded saying like more on AIML, how to run inference AI model in local in Docker locally. That's a good topic for a blog post which I've recently wrote. So definitely I will cover that. Agentic AI, yes, we have a lot of slides on Agentic AI. And as the title of the event says, right, it is all about the Agentic AI. So we will cover that. Let's wait for a few more seconds and try to see. I see a lot of folks still typing. And even if you have any kind of a question, just go ahead and post it, and so that I will try to cover whenever we are going to talk about the model runner. I will cover a few of the demos on the model runner, then Agentic AI, the MCP stuff. So definitely I can go ahead and cover it. Okay, I want to know how to use Agentic AI in my real use. Yes. So we have a demo called Secure Coding AI Agent, and that demo basically covers this. Okay, hands-on MCP with Docker. Yes, we do have plan for Agentic AI training. Yeah, one of the things which I have seen, lot of time I get, there are people who are quite new to the MCP stuff, right? Is they are still living in GenAI 1.0, and now we are talking about the GenAI 2.0, which is an Agentic AI. So definitely, the plan is to have more and more virtual session in 2026, because I know there are a lot of folks who reach out to us saying like, you do a lot of in-person meetup. Why don't you do the virtual? We used to do like 3 years back, but going forward in 2026 will be the year you will see more virtual event than in-person events. Okay, learn about Docker. So to learn about AI ML concept, understand available frameworks. This looks good. Okay, and I can see there are like 8 different topics on AI, and the rest of them are in the Docker. So I could see like learning about AI usage in Docker. Okay, there are few folks still typing, so let's wait for a few seconds, and then based on that, uh, I will try to modify our agenda in such a way that I will cover more on the agentic AI side of it, right? Need to learn more about ML and AI. Okay, let's look at the Docker. In the Docker side, we have a AI usage in Docker, more on AI ML. Okay, most of the topics are AI ML. But again, thanks a lot for taking your time trying to write all of this stuff. And I can see people are slowing down now. Uh, one more second, and then we'll jump into the agenda. And as I said, right, this window will be open for next 2 or 3 days. Definitely go ahead, put it in the Slido, whatever you want. I am going to look into it after the after this session. And I have been working very closely with the Docker AI team. So if you have any queries, say you are implementing some kind of an model training or inferencing and all of this thing, I can definitely help you out on that. Okay. So thanks a lot. I will jump back to my slides now, and let's move to the agenda. Now, this is how the agenda would look like. And as I said, right, most of the topic which we were discussing in Slido has been covered here. So we'll start with the lab 1, lab 2, lab 3, and lab 4. I've divided so that it is very easy to understand how we are going to position the whole workshop. Lab 1 will be like, we will see how to install Docker Desktop, irrespective of whether you have a Windows, Linux, or Mac. You can always go ahead and install Docker Desktop, right? We'll also see how to enable Docker Model Runner. Just like Olama, you can run AI model locally, and that is called as the Docker Model Runner. Now, there is a difference in between Olama and DMR, which we are going to talk. So in short, we call it as a DMR. We'll also see how to configure the MCP toolkit. This is where your model context protocol come into the picture. So if you go to the chat GPT and type something, it might not know about what is happening in the current world, right? So imagine your chat GPT has access to your web application or your database. That changes the whole game, right? The reason being, now you have access to the real time data. So that is all the MCP is all about. Basically, you are providing a context to your LLM. One of the thing which we have recently worked is like, say if you want to run some kind of a playground locally, we call that concept as a lab spaces. This was very recently introduced by my team. I kept it as an optional because most of the things we are doing in the VS Code, but you can even run VS Code on the cloud itself or on the browser. Sorry, on the browser. So I kept it as an optional because we are not going to spend more time into it. But I will just showcase you that okay, these are the lab spaces and marketplace, how it look like. You can spin up those when you are doing some kind of a training or on those kind of a stuff. Now, under the lab 2, we are going to cover on Agentic AI's microservices. We'll see how we have been shifting from GenAI 1.0, which is the chatbot, to GenAI 2.0, which is multi-stage system, multi-agent system. Okay. We'll also look at what is difference between generative AI versus agentic AI. And trust me, if you attend this session, most of the stuff which has happened in the last 2 years, you will get to know where industry is basically running. We are not just here to run a workshop, but I have few of the slides where I will go through. And these slides are something which is very generic slide, right? You don't really have to do a vendor login. You don't have to follow or install any kind of a third-party tool. You just need Docker Desktop. That's it. Then I will touch upon the building blocks of agentic apps, right? I will talk about how MCP fits into, how LLM fits into, what are the MCP tools. And then we'll also talk about the MCP gateway, which is again in the lab 3. How Docker is trying to solve this problem. Basically, the challenges which you face with in terms of security, in terms of discovery. And then we will do a kind of a hands-on on getting started with Model Runner, how you can run model which you can download from Hugging Face as well as Docker Hub. So there are a couple of registries where you can just go ahead and pull those AI models. Now AI models are just like an images, but they are different, right? Because AI models are more like vector representation. They are just numbers. Images have file system. AI model doesn't have a file system. So we'll cover all those stuff under lab 2, which will last for 30 to 40 minutes. Then I will jump into lab 3, which is Docker, MCP toolkit, and MCP gateway. Docker has been investing so much time ever since the MCP was introduced back in, I would say, December 2024. So there are a lot of stuff which is happening. Then we'll talk about the MCP difficulties and challenges, how Docker is uh, um, solving this problem, what are the overview of MCP gateway. Then we'll jump into the lab 4, which is more like building a secure AI coding agent. So we'll talk about the multi-agent system right now. And single LLM system is a trap. So I have a couple of slides which talks about it, how these AI agents talk to each other, how they collaborate with each other. So I have picked up a very exciting AI coding agent example where I will go through the high level project repository, how to break down these components, the Agentic Compose, whatever the tool you were using in the past, like the Compose file, you can use the same tool to uh, bring up especially the models, to bring up your agentic application. Okay, we'll test the agent and then we'll wrap it up. So if you look at the timeline, all the 4 labs would take 2 hours time. But in between, if say you are at home and suddenly there is some kind of an urgent work which came up, right? In between, you can just stop it, focus on your urgent work or personal work, come back, because these YouTube videos will be available soon after we finish this workshop. Okay. Does this look good? Is there any other topic which you want me to cover? Just put it in the chat window. I would happy to go through it. So I can see. Thank you, Aman. I think you have been answering a lot of these questions. I see one of the question from you saying like, I'm researching about Langsmith Docker deployment with AKS. Do you have any pointers? Definitely, we are not going to cover it, but I can. I have few of the demos related to the agent development kit. I think that is something which we are going to cover. But yes, we while going through the lab 4, we have a repo called as Compose for Agents, and where we have couple of like 8 to 9 examples which talks about um, all those frameworks. I have picked up Cerebrus for at this point of time, but we have all the others, which includes your Langsmith and all of these things. So I would suggest you, maybe you can just have a look when we are talking about lab 4, and then maybe you get some kind of an ideas how to build it up. But most of these demos which we are going to run are basically on the local machine, but through the Agentic Compose, we also, I don't know whether you are aware, but we have a very good relationship with all those cloud vendors. So we are working on how you can take this particular application and push it to AWS, AKS, as well as the Google Cloud. So I've already shown example of Google Cloud in one of the conference which happened 2 months back, where we have introduced a new Google Cloud command called as G Cloud Run Compose Up, and that basically brings up your whole application on the Google Cloud itself. But again, this is outside the scope of this topic. But yes, in future we can always go ahead, pick up these kind of a framework, and I can talk about it. Okay, so I do see one suggestion that you can just go ahead and remove. So let me see if I can remove this banner. Okay, here you go. So I will jump back. Thank you. I just removed. We'll start in 5 minutes and all of this thing. But yes, so let's go back and try to see what you will learn today. So today you will learn about how to deploy a multi-agent system using Agentic Compose. This is again something which is very new, which recently came, like I would say, 2 months back. We will learn about it. We'll understand how to orchestrate the multiple AI agent for a specialized task. Say, for example, whenever you choose model, right? It's not like random. You go and pick up the Llama model, right? There are more than 12 lakh models in Hugging Face today. Okay, more than 12 lakhs, and you should know which model does what, right? If you are seeing some simple reasoning, and if you are picking up some kind of model which is like quantized, and which is not meant for the reasoning, then it doesn't make sense, right? So So that's the reason, right? So whenever we pick up a model, we should be very careful which model which we are going to pick up. In today demo, I am going to show you two models which you might not have heard about, right? Though those are popular models, they are lightweight, but those are not like a coin model which is like 8 GB and all of these things size, right? So we need to understand how these model with each other, and especially for the agentic application. We'll also explore MCP gateway and its capabilities. One of the thing which I am not going to cover in this, but I want to talk about is offload. Say you are playing with a model, okay? Say I'm building some kind of an application, and I picked up some kind of a heavy model which is like more than, it requires NVRAM, and it is not running on your local system. So what we do, we have a feature called as a Docker offload, which means that now you can spin up an instance over the cloud with a GPU, which is NVIDIA GPU, and these instance will be like close to around 23 GB in size, right? And now you can play around with it and then again come back. Okay, so it is not for the production; it is only for the testing. But yes, we do have a feature like Docker offload, and it is damn easy. Just one click, and you can redirect to the cloud, right? But anyway, it is we are not going to cover in this because again, this session is more on AI and ML, and as well as more talking about the MCP. So let's get started. So the first thing which I want you guys to do is whatever I'm going to talk today is available under Docker workshop.vercel.app. Okay, Docker workshop, it is a single word, .vercel.app. Okay, you can just open up, right? And I can quickly show you. So if you go to Docker workshop.vercel.app, you will see that it's a very simple, plain text, nothing fancy, but it has all the great content. And these are the workshop which you can start from day zero. The reason why I captured this is because I do see like 80% of you said like you are new to Docker. So for you guys, this is one portal, because if you go to the docs.docker.com, you might get lost because there are millions of those pages, right? In this, what I have done, I have tried to use, okay, how to get started. The source code of workshop is available. Anyone can come in, they can contribute, and you can go through the prerequisite, right? How does this prerequisite look like? Docker desktop, WSL2, you need to install Node.js, access to this repo, enable the model runner, and we are going to download these three models. Okay, so what I would suggest at this point of time, run this command and download these two models from Hugging Face and one from Docker Hub. So I suggest you to just go ahead, copy this command and run it while we start our presentation, say in our demo in next 30 to 40 minutes. You should be able to go ahead and play around with this model. But these models are a little heavy, like 1.2 GB. So based on the network, it will take time. So what I want you to copy this command and just paste it on your Docker desktop machine, okay, on the terminal, and you should be able to download this model. So yeah, and this is under the prerequisite page. You can see here the prerequisite page. If you want to learn about the inner loop development workflow, I have kept all of these pages. Today we are even going to as we are talking about the model runner, you can see here there are few of the projects which I'm going to pick up. One is a GenAI chatbot. We'll go through all those architecture and everything. The other one is a product catalog chatbot. Okay, so all of these things. I can see one of the question is like, is there any free tier available for Docker offload? Yes, it is available, but it is just for a very limited time. You can join the beta version, and based on that, you can join it. Okay. So coming back to the question, to the particular, all of those labs here, we will first cover Docker model runner, then we'll come to the MCP catalog. So if you can see here how to get started, what are the overview. I do have an architecture diagram of MCP. I will explain it in the form of the slides and all of this thing. And then we will also go through, say if you want to use GitHub MCP server, you want to use Docker MCP, GitHub with Gordon. Again, it's like our own chat GPT kind of stuff. And then we have a Kubernetes MCP server, how to configure a Slack MCP server. So what I have done, first you will see a diagram, and then there are step by step. Okay, we don't have to now go through all of them. I'm just walking you through like how it is going to look like, right? I have also labs related to the Docker offload as well as the Agentic Compose, right? And these all labs are tested labs. So if you run it on Docker desktop, it must run. And if it is not running, you know where to reach out. Just go to the GitHub repo and try to raise the PR, right? Or say issues. Okay. Today, as I said, right, a couple of hackathon recommender, Agentic Compose, product catalog, A2A, multi-agent fact checker. What we are going to pick up is a dev duck, and we are going to do a kind of this kind of an architecture. So we are going to see how to implement, and these can be implemented with with just one Docker Compose file. So there are a lot of exciting stuff. I would suggest you, the first thing you need to do is go to the prerequisite, ensure that all of this, if you are on a Windows, enable WSL2. If you're in the Mac, you don't have to install Node.js. Let's keep it optional at this point of time. But if you are, say, going through this inner loop development workflow, definitely if you are very new to Docker, you need to go ahead and try these labs. So each of these headings has some kind of a lab, and you can just get started with it. Okay. So in between, when I am preparing a slide, you are stuck, just come back, copy those commands and paste it. Okay. Looks good. So I am again showing you for them who joined just few minutes back. Okay. Dockerworkshop.versal.com. Okay. Let me go back to the chat window. Okay, any Docker AI training provided? So no, we don't have any Docker AI training, but you can definitely reach out to us, support at the docker.com. Definitely we can see how we can, if your company is a part of our, as a part of the client or customer, definitely we can go ahead and help you out. But yes, we do have a plan to do some kind of a training in maybe in 2026, but it will be more like a community event, not like a full-fledged paid training kind of a stuff. Okay, now let's jump into the prerequisite and setup. The first thing you need to do is install Docker Desktop. Okay, go to docker.com/products/docker desktop and install Docker Desktop on your machine. Okay, I assume that most of you have already installed Docker Desktop, so we should not worry about it. Okay, the prerequisite too is really important because, as I said, right, we are going to play around with an AI model. So we need to ensure that all these AI models are downloaded. So I want you to go to the settings, AI, enable model runner. So I will quickly show you how it look like. So if I have a Docker desktop, so just give me few seconds where I'm going to charge my system here. Okay. So if you see here that if I open a Docker desktop here, go to the dashboard. Under the dashboard, you will see that there is an option called as an AI, right? And you have an option called as a Docker model runner. Ensure that it is enabled. Okay. Now, when we are dealing with OpenAI endpoints, that is where your host side TCP support come into the picture. So select both of these options. First, enable model runner, and the second is enable host side TCP support. And then the default port which you will see is 12434. So we are not getting into the cores, right? But ensure that these two options are enabled. Okay, these two options has to be enabled. You go to the settings here, AI, and ensuring that if you don't see this option, it means that you are running a older version of Docker Desktop. So ensure that you have a latest version of Docker Desktop installed on the machine. I'm going to close this, come back to the slide. So enable Docker model runner. Just give me a thumbs up if you are able to enable it or it is already enabled on the chat window. Okay. I see a couple of questions here, but we can take it later point of time. Let's not break the flow which we have. The third one would be pulling these models. So we need to download these AI models. So right now, if you see, um, we have a couple of these models. As I said, right, go to the workshop, just ensure that all these models are downloaded. You have a Jan Nano. As I said, right, we are going to play around with customized models, right? So Jan Nano, Lucy, they are available under the Hugging Face. The command is going to be the same: Docker model pull and specify this path. And if you are downloading from from Docker Hub, then you need to add a namespace in front of it, which is an AI Llama 3.2. Okay, ensure that these models get pulled. One thing which I want to say is, in between, if there is any kind of a network disruption which happens at my end or at your end, just wait for 2 or 3 minutes while we just come back to the session. But be there and try to see if you can run this workshop on your own. Okay. So these are the, like, these are the prerequisite. So what I have done here, if you go to Docker model runner and you go to the models here, so what I have done, you can go to the Docker hub here and search for llama 3. Okay, now you can see here there are different models, right? You just have to click pull. Okay, you can see here llama 3.3 has been downloaded 50,000 times. So you might be curious about what people are doing with these models, right? So yes, so again, these are the 4 models which I have already downloaded. Ensure that you have downloaded already this model. I will talk about what these models are all about. The first one is like around, you can see the size here. It is more like in a GB, right? But since when you download this model from the Hugging Face, you might see like the size, it is not showing correctly. But if you see the llama which is in the Docker hub, so this is again a kind of enhancement which we are doing, and trying to see like when we download anything from the Hugging Face, so the model should be in the in the proper size. So but you can see the llama 3.2, it shows like 1.22 GB. Now if I want to chat with this model, I can always go back and say hello. Okay, which means that in order to get started with this model, I don't really have to go ahead and build a chatbot around it. Like I can even do it without it. Okay, so when I say hello, you can say how can I assist you, and I say write a poem on Docker and AI. So once I do this, you can see here it start writing the poem, right? Okay, so which means that this is the way how you communicate. And in between, what happened that if you have a GPU on your Mac machine, like I am in Mac 1 M1 M1 Pro, so it start using those GPUs also, right? So I will talk about that. But coming back to my slides, ensure that you have all these models downloaded. And where to find? Go to dockerworkshop.vercel.app, and you should be able to see all those models. Okay, I have Mohammed Salman. He said, like, could you please show me once again that Docker desktop setting to enable AI? Yeah, definitely. What I can do, you go to the dashboard here, click on the settings, right? On the top right, there is a setting. Go to AI, and this is where you basically see the option where you can enable Docker model runner. Okay. um, I hope this is useful. Okay, going back to my slides, let's continue. Now, why we choose this model, we need to have a clear understanding of what these models are all about, right? So if you see these are four models which we have downloaded: llama 3, Mistral, GenAI, and Lucy. Now few of these models are what they are very good in reasoning part. Okay, they are uh, they are very good in the listening part. GenAI is a tool centric, which means that whenever you pick up the model, if you are trying to integrate with the MCP, when MCP uses any model, then the model should support the MCP tool calling, right? So that is the reason the model should support the tool calling. So why we picked up GenAI and Lucy? Because they are optimized for the tool use. And that is the reason why I picked them up. For whenever you are playing around with this agentic AI application, sometimes what happened that you pick up some kind of an MCP server, and then suddenly you pick up the LLM model. Say if I pick up any of the small LLM models, right, which doesn't support the tool calling, then it won't support and your application won't work. So ensure that the models which you choose should support the tool calling. Okay, so llama 3 supports that, Mistral supports that, GenAI and Lucy are the one. So we are going to run GenAI and Lucy locally because they are quantized coin model. Okay, they are very small coin model of around like 1.2 GB, not more than that. Where we have a llama 3 which is like close to around 4 to 5 GB, right, in size. Now each of these models are characterized based on the billion parameters, based on the parameter they have. So llama 3 has 1 billion parameter, right? And Mistral is close to around 7 billion parameter. We have a tool centric researcher which is Jan Nano, which is like 4 billion parameters, right? And 1.72 is the Lucy. So we are going to run Jan Nano and Lucy locally. Whereas we are going to pick up one of the Llama model, which is available in the Cerebrus, which is the cloud API. So we will see how the model in the cloud as well as in the local can be consumed. So we need to understand each of these models. So when you go to the Hugging Face next time, try to understand what this model does. Okay, and based on that, you can take a decision. Uh, okay, so again, you can always cross check, because I keep on updating all those slides, but the whole idea is to show you the model selection. The final stuff which we are going to do is MCP, because Agentic AI requires MCP. So we need to go ahead and enable Docker MCP toolkit. We will add GitHub, Firecrawl, Context 7, and Node.js Sandbox MCP server. So how to do it? Go to a dashboard. So let me go to the dashboard here, go to the MCP toolkit. You will see that there are more than 300 plus MCP server in a containerized format. So we provide you with all the catalog, right? So I say if I want to search for Grafana, so I can see there is a Grafana. I can click on it and I can always go ahead and configure it. So Grafana is already added. So once you add Grafana, you need to pass some kind of a configuration. It will appear in my server. So right now, if you see Firecrawl, GitHub, Context 7, these are the MCP server which we are going to use it. Okay. But before that, if you are not able to see this option, what you need to do is go to the settings, go to the beta feature, ensure that you have enabled Docker MCP toolkit here. Okay. This is required, okay, for our lab. Ensure that it is enabled. If you don't see any Docker MCP toolkit on the left hand side of your window, Docker dashboard, okay, as I said, go to the settings, go to the beta features, and enable this Docker MCP toolkit, and it should work. Okay. Now, the reason why we are picking all this MCP server, because we have the few other example I want to show you with the Cloud desktop on GitHub. We have a Firecrawl MCP server, Context 7, and Node.js Sandbox MCP server. Okay. Uh, I hope we are running on time, but even if you feel that okay, there is something we are running fast, then let me know, because we are yet to cover a lot of stuff here. So let's be quickly on that. Okay. When I say add Firecrawl and Context 7, it is just like you can search in the so let me go back and show you how it look like. So let's look at GitHub. So if I search for GitHub official, it requires a configuration. Okay. Either you pass personal access token, or you can even pass OAuth. OAuth is more like you are authenticating through Google. Okay. So you can just, this is the easiest way. Otherwise, if you want to go through the personal access token, then what you need to do is go to the Docker workshop, click on MCP catalog, and pick up this GitHub MCP server and Cloud desktop. You need to follow all these steps to get a personal access token. Now, one thing I want to mention here is whenever you pick up this personal access token, ensure that it has all the permission which you require. Say if I want to create any repo using a kind of a Cloud desktop, right? Ensure that the permissions are all in place. Okay. Now coming back to my dashboard, this is on GitHub official. For Context 7, which we will require for Express documentation, I can go ahead, click on it. We don't need any kind of a configuration here. So which means that you don't really have to get any API key or anything. Just enable it and ensure that all these servers which you enable should appear on my server list. Okay. So I have a Mongo, I have a Firecrawl, I have a Context 7. We don't require Mongo or Grafana or anything, but we do require Node.js Sandbox. Again, it does. This will be required to spin up. So my MCP server is going to spin up a container, do the testing, and give me the result. Okay. So it doesn't require any configuration. You just go ahead and add it. Each of these MCP servers has tools, number of tools. So you can see here there are 7 different tools here. Correct? The 7 different tools. So we'll take a look at this at one point of time, but this is how my server should look like. There are a couple of them which I don't require. Say I can remove archive, I can even remove Grafana from my list. Even Mongo, I don't require it. Postgres, I can remove it. Sequential thinking is something which I might require, but again, it is not compulsory. So Context 7. For Firecrawl, I would suggest there is a kind of, you will require an API key for Firecrawl. Go to the firecrawl.dev and get an API key. It's very easy to register. But for our lab, we don't require it. Like even if it is required, I have few of the example which I'm going to show you, but it provides you with the 6 tools and ensure that at least you have context 7 and Node.js sandbox. That's it. That is required for our lab. Okay. Now coming back to the question, I do see okay, there is no beta feature, which means that you're not running the latest version of your desktop. So ensure that you should have a latest version, then only you will get all those stuff. Okay, so I'm going to skip this lab space, but I'm just going to tell you about very high level. We are not going to go ahead start the lab space, but the idea is when you go to a Docker extension here, go to the dashboard. uh, under the extension uh, Under the extension, if you click browse it, you will see a lab spaces here. Now what is this lab spaces? Lab spaces are basically a locally running playground. Say if I want to build an agentic app with Docker, I can launch this lab space, right? We are still building it, and then start doing all those following or follow all those steps. Like in my last workshop which we did, um, um, for the GenAI, I just had a complete workshop on the lab space. So I want you to just try it out. Right now, we are expecting a lot of people to come and even show us the demos, the DHIs, the Docker hardened images, how to fine tune the models. These are in the form of the lab spaces which we have created. On the left hand side, you see all those instruction. On the right hand side, all those commands. But anyway, maybe if I have time, I can just go through it. But at this point of time, you can click on any one of them, launch it, and you should be able to use it. Okay. uh, at this point of time, we will stick to our agenda, and then let's go through this. um, Now let's talk about the agentic AI, because the first 30 minutes I want to spend more time on what is agentic AI as a microservices, right? Till that time, ensure that you have all those models downloaded so that we can quickly start with the demo. Now if you go back 2 years ago, right, so we were more talking about the chatbot, right? The chat GPT is an example. It was more like a reactive system, which means that you ask the question and it respond you back, but it doesn't have any idea about your infrastructure. Say you go to the chat GPT and say like, can you deploy a Kubernetes cluster on my machine? It will just give you an idea about how to do it step by step, but it was not taking any kind of an action. So it is more like a reactive system. It was responding to what you are questioning. But today, if you see, we are talking about a multi-agent system. It is a collaborative network of agents. They are not just answering your question, but they are now reacting to it. And if you see, there are two dimensions. One is level of complexity and level of autonomy. Okay, level of complexity is, it was a simple chatbot. You try to integrate with your front end, back end, database, and it works. But the agent system is more like each of these agents are powered by the LLMs, right? So say if I'm running my own restaurant, if I have a kitchen agent, if I have an order agent, if I have, say, chef agent, so which means that each of these chef will require an LLM. So which means that we are talking about the multi-agent, multi-LLM architecture. So that is where we are moving to, right? Now these agents are so intelligent, they work together, work with each other, and try to uh, plan, try to execute. There is a goal which is defined, and they learn from their mistake. So if I move to this particular diagram, so our generative AI is more like starting from the prompt, going to the LLM and generating a text. That was the limitation of GenAI 1.0. Now what we are talking about is an agentic AI, where every task has some kind of a goal. It is being planned, it has been acted. There is some kind of reflection. Means, say there is, if the agents are stuck, they are intelligent enough to go ahead, fix it on their own, which means that the self-healing capability is also there. Okay, so agentic AI is more like a collaborative way, and each of these are being done by the different agents all together. So that is a difference. Now, if you look at the typical agentic AI application, this will give you a high level picture of how it look like. A user, say, for example, I go to the AI assistant or any of the cloud desktop and I say, show me all the GitHub issues and create a Notion task list. Okay. When I say that, what happens that this is a user input. It goes to the agent application, which is like a project manager. So we call it as an orchestrator. Okay. It has a memory, it has a feedback loop. Now, what happens that it goes to the LLM. LLM could be coin model or llama model. And now the context is provided by this agent application. about the context to the LLM is provided with the tools. And these tools which you see here, right here, the GitHub, Notion, and these are nothing but an MCP server. So when we say MCP server, it's basically more like a logical, but the tools are the one which are the actual tools. Like if you go to the Cloud desktop, right? And if you try to see, you won't see the MCP servers there. You will see MCP tools. So that's why we call it the tool calling. Every LLM doesn't support the tool calling. You need to pick up the right LLM which supports that. Okay. And again, the GitHub is again connected to the external GitHub, account. The Notion is again wherever you are hosted. So these are like an APIs, right? So the whole agentic application looks something like this. So what we are going to do, we are going to cover first LLM. We'll start with the model, then we'll come to the MCP, which are like tools, and then lastly we will have agentic app, how to build those, and that will cover our whole agentic AI application. I hope these concepts are damn clear so that you understand whenever someone says agentic AI application, this is very high level picture. Now there are components like MCP gateway which come into the picture, but this is an agentic AI application. I do see one of Mohammed saying like, can we get this slide? Yes, I will be sharing these slides in the form of a PDF. You can always go back and look into it. So this is what I was talking about. Like LLM is more like a reasoning. Memory is, understanding the context. Orchestrator is like a project manager. Execution is like for the MCP tool. And then we have a self-correction, self-remedy, and all of this thing, which happens with the feedback loop. Now, talking about the challenges in building this agentic application, there are three challenges which I have seen in the past like 6 to 7 months. First is a learning curve. The reason why I'm saying, because if you look today as an MCP, like there are more than 8,000 MCP servers available in the market, right? And that is on the GitHub. People are just downloading in the form of Python or Node.js and running it. So the second one is like a tool discovery. It is very hard. If you go and search for GitHub, you will see 5 different repo, and you don't know whether which is official and which are not, right? So which means that tool discovery is a important part and is a difficult part altogether, right? And then the privacy security, because now you are providing a context to your LLM, which means that you are getting access to your laptop, to your workstation, to your cloud. So AWS has 32 MCP servers, which means that now you have access to those AWS cloud. So you need to be worried about privacy. So this is one of the survey which was done with the IBM AI Enterprise app. 76% of dev doesn't consider themselves professional in GenAI, and I'm talking about the GenAI 1.0. Okay, forget about GenAI 2.0 itself. 76%, which is a big number. People are finding it difficult. The reason there is no one website which is claiming that okay, we have all those MCP servers out of those 8,000 MCP servers. So this is again someone posted in the Reddit, very popular. I forgot to I have the source added into that, but you can see that there is no any one single stop for all your MCP server. And the third one is the privacy and security, right? We have a couple of slides which I'm going to talk about it. So what Docker does, Docker solves all of your problem. The reason being we are looking at this problem statement and we are working on it ever since Anthropic announced the MCP. We have been doing a couple of stuff, and that is the reason why you see the catalog of 300 containerized application, which is not a small thing. Like I would say, like all of these are coming from the community. They are known publishers and all of these things. So Docker is here to help you with the trusted content, because this is what we are going to manage. You don't really have to go to the GitHub and download some random GitHub repo and run it, right? So agentic application needs three things. Okay, let's be clear. Okay, models, tools, and code. And I'm going to show you. When I'm talking about the models, it's more like I'm talking about the model runner, AI models, right? When I'm talking about the tools, it is like an MCP tool. And when we are talking about code, it is like the code which you are writing in the Node.js or Python format, right? How these agentic application are being built. Let's talk about the models. Today, you see there are tons of models. As I said, right, 12 lakh models in Hugging Face. And what is that? If you pick up any of the models, say Llama 3.2, it has been trained since till 2023 or 2024, which means that Llama 3.2 only knows about all the information which has happened till that particular time. Now if I try to spin up models and try to go through and ask anything which has happened today, it might not know. Why? The reason being, these large language model is nothing but a snapshot of your data trained on a specific set of knowledge. So these are snapshot of data, that's it, not even more than that. Okay, it accept text, it images, video formats, it can answer the questions and all of this thing. And you can very easily, if you want to compare it, you can take an example of a simple calculator which is like a small language model. Then we have a middle model which is like a scientific calculator, right? And then we have a large language model which is just like a laptop. And if you look at what differentiate all of them is like a billions of parameters, 1 to 3 billion parameters. A small language model, we have a medium model which is like, close to around 7 to 15 billion. And then now, if you see this slide I prepared around like this particular slide prepared around 1 year ago, now you see we have 200 billion and more parameters now. All these new models like Sonnet 4.5, these are, they fall under 70 to 200 billion parameters. And this is massive because they have all this. Say for example, the Claude 4.5 has an intelligent till what, till I think March or April 2025. So which means that now all these models are being trained and they have been announced by the Anthropic, all those, OpenAI and all of this thing, right? So these are few of the examples. I am not sure about the entries, but I can show you that this is how we categorize all these. People are talking about the SLM, right? Because the reason being, based on the resources, you don't really have to spend more time into downloading all those large language models. But this is how it look like. Now, when we talk about the single LLM, it is mostly the single LLM is a trap, okay? Because we are using one GPT for all sort of these activities like music generation, code generation, image generation, right? We have a translation, data analysis, code analysis, which means that if you are just using Chat GPT for all the stuff, it is not going to help you out. As I said, each model is trained for a specific use case. Few models are very good. Say if I want to generate an if you want to write say generate an video, if you go to the Chat GPT and ask, definitely it is not going to do that, because you need to have a Sora or all those, you know vision models, right, which can generate the images in a better way. They will generate, but it is going to hallucinate because they are not expert in that. It's very very easy example would be like, say you are an expert in a Node.js. Okay, if I give you some Python code to write, definitely you want provide me with the best, the code with the best practices, right? If you are a developer of 15 years of experience, and when you compare it to the just 5 years experience, there is a difference, right, based on the experience, right? So GPT model is running one frontier model is basically a trap. You should know what model does what, right? So based on that, you choose it. And how to start playing around with it, we call it as a Docker model runner, which runs model next to your containerized services, right? And the difference, what this Docker model runner brings is like, if you are using say some kind of tools like Olama, mostly what you do, you run it inside a container, right? If you're running on the cloud or if you're running on the Docker desktop, right? Which means that if you have an NVIDIA GPU, you have to go through all those configuration changes to give it access to the GPU, right? What we are saying is, if you have a model runner, if you're on a Mac machine, you don't really have to worry about it. You just run those model, and because of the component called as the Llama CPP, it loads this model into the memory, and it has access to the GPU, which means that I don't have to go through all those NVIDIA specific configuration right now. It will just work. The reason being, we have already integrated with it the Llama CPP model, which basically loads this model into the memory. Okay, so a traditional GenAI development goes through all those manual configuration, whereas in model runner you just have to enable it. That's it. And I think we have a couple of slides which talks about it. We do have a command called as a Docker model. As a first class citizen, it pulls the model from registry. It works for both for Hugging Face as well as the local model. Okay, and this is a command to pull any of the model, the namespace slash the name of the model. So don't forget the namespace here, AI slash. And from where it is coming from, it is coming from your Docker Hub. Okay, this is a management interface which we have already looked into it, how to manage all these models. So it has all those, we have both CLI and API for managing these models. CLI would look like something like this. Say you can do all this get post when you are writing your agentic application from within the container. If you try to connect to these AI models, you have to use model hyphen runner dot docker dot internal. So ensure that most of the time I have seen people facing this problem, like they just bring up the application and try to they run the model on the host, but they try to communicate from the containers, right? Your container should have access to it. So ensure that you provide this if you are on the host machine. So right now what we are going to do is on the host machine, right? We downloaded the model on the host. In that case, we use localhost 12434. Do you remember 12434? This is a setting which we did in the initial steps, where you enable the host side TCP IP, right? So ensure that this is a default model, but the more default port, but you can use one of your choice. We also use, and say you are coming from the OpenAI world, so we have an API endpoint. You can just, we support all of these OpenAI endpoint, get engine, llama cpp v1 model. So you need to provide that particular path, and I will show you next quickly an example for this. Embeddings, list, model completion. Okay. I can even run model runner as a part of the GitHub workflow, because now, say if I am on the Linux machine where I'm not running on Docker desktop, you can still run these model inside a Docker container. So we provide you with both the capabilities. Okay. There are few of the FAQs which you might which you might be keen to know about. Are these model running in container with GPUs? It depends, because in Docker desktop we run it on the host, not in the container. But when you are in the Linux machine, then you run it as a container, okay, in a Docker C, so community edition. Now, where does this data go? Does it stay local? Yes, that's the beauty, right? When you run this model, you don't really have to go to the cloud APIs and expose your anything, right? So it is just like everything remains inside it. And there are a couple of all the other stuff. Yes, you can publish your own model. You can go to the Hugging Face, download it. One of the thing which we really require to do is Docker Compose support for model, and this is the demo which we are going to see now. When you use a compose file, just like how you specify these compose services, we can also specify the model. So models are the first class citizen. But remember one thing, okay, even though these models are specified as a services, you don't run it as a container. So you won't see any container running. It runs on the host machine. It's just that we want to include it so that it should not trouble you in managing two different things, right? So even if you see this example, I have a service which is, say, backend or front end. It depends upon the model LLM, and I'm specifying the model as a small model. And but this models is not running as a container. It is running on the host machine. I'm going to quickly show you the demo here. Okay. So let's jump into the first demo. Go to dockerworkshop.wurzel.app and click on Docker model runner projects, and we have a GenAI chatbot. So let's build this particular chatbot. Okay. This is an architecture we are going to build. You have a front end React, back end as Go. We have a model runner, Llama 3.2. What I have done this time is more like integrating observability stack, okay, into the chatbot itself. I have Prometheus, Jigger, and Grafana, right? All those things which are running. And you need to clone this repo called as github.com/docker samples/GenAI model runner metrics. Okay. I have a video which walks through the complete code, but if you haven't watched that video, definitely this is a time where you can try it out. As I said, this was an initial, like around 6 months back. You need to enable Docker model through the beta features, but now since it is not beta, so you don't really have to worry about it because we have already enabled it. Ensure that you run Docker model pull command. So let me open a VS Code here, and this is how it look like. Say if I want to pull this model, which I have already downloaded. When I say Docker model pull AI Llama 3.2, you can see here 1.22 GB in size. So I have already pulled it. Let's jump directly into a few of the stuff here. So I have a compose.yaml file here. Okay, let's go through this compose.yaml file. So I have a couple of services here. I have a backend, I have a front end, Prometheus, Grafana, Jigger, and I have also added a new service called as LLM service, which is a model. Okay, and I'm specifying as in one way you can directly provide a model here, but this is since we built this particular demo around like 5 to 6 months back, so that is why you have both the provider as well as directly you can specify the model also. To just give you an example here, if you see there is an environmental variable for this backend.env, I can jump into the backend.env, and this is a way, since I am running this model right on the host machine, then I can always go ahead and pass those as either localhost or say host.docker.internal. Okay. Because MacBook, when you are in the Linux machine, you can always go ahead and pass this, but in the MacBook, you always specify, you don't specify the local host, you provide as a host.docker.internal. Okay. These are basically the settings which we do for the Mac machine. But if you see the port which I have provided, the engines Llama CPP v1, okay, I am providing the model name as an AI/Llama 3.2. That is the entry which you require here. Okay. Now I can show you the compose file. So this is what the compose file we were talking about. So this is a backend service which is running on the go, and the network depends upon LLM. We have a front end service which is running in 3000, which is React, and the Prometheus. I'm passing all those variables here, right? For the Prometheus, I have a Grafana and Jigger. So we are using this observability stack, which will collect all the information about our AI models, the Llama CPP components. Okay, it is not a full-fledged application, I would say, for the production, but just for getting started, this is one of the exciting project which you can even contribute. And then I've specified the Llama, ensuring that I have Llama 3.2 already available. Okay, so what I need to do here now, I can get into this particular project and ensuring that I don't have any Docker desktop running. So you can see here, none of the container is running here. I can say Docker compose up -t, and that's it. Okay. For the first time when you run, it will take some time because all of these, Prometheus Jaeger has to be downloaded. But if you see here that once I run this service, you can see here Prometheus Jaeger backend, front end, everything comes up, right? If I go to the Docker desktop here and look at the containers, right, I can see that you won't see LLM as a service here because it is running on the host machine. Okay, but rest of the services are appearing as a container. I hope this is damn clear that whenever you use LLM, we are not running AI model inside a container. The reason being, when you run inside a container, it has to go through all those configurations. Say if you have NVIDIA GPU, you have to install NVIDIA container toolkit, which you don't have any option, right? You can't do it on Mac machine itself. So when you have a MacBook, it has a GPU and it consumes it. Okay, so once you have this, all I can do is open port 3000 here, and this opens a GenAI chatbot. Okay, and if I try to expand, I can see input output token. It's like a chat GPT. Okay, but it gives you all this information about, okay, as I said, right, there is a component called as Llama CPP, which loads your model into the AI memory. So here I can say hello, and you will see that the response which we get for the first time, right? You can see here the input token is 2, output token is 17, right? And the response is very fast. Okay, now to show you that it uses GPU, what I'm going to do, I'm going to open an activity monitor. Okay, so I will open an activity monitor, get into GPU history here, and we can track what are those services running. So if you can see here that com.docker llama server is running here, and right now it is an idle. Okay, it is damn idle, right? Now let's make it quite stable here. So if you see here, my GPU spike is not there. It is not being used at this point of time. Let me go back and say write a poem on Docker and AI, and it's a poem, I would say 5,000 words poem on Docker and AI. If you can see here, right, the output is, it is writing so fast. The reason being, it is utilizing the GPU, and if you see here, the GPU will spike right now. You can see till this point. Okay, it is utilizing a GPU, and you can see this particular service which is running. So you can see here the usage. When we were not running any prompt, it was right here, and now it has spiked. Okay, and the output which you see is, it was quite fast, right? Definitely look at the speed where it is typing. Again, I have so many services running on my same machine. I'm presenting in the same and all this thing, but still, it gives me all those, the local chat GPT kind of a feel, right? Now this is one part of the story. Okay, and you can see the output and the input token. Okay, how they are increasing their total request and all this thing. Now when you click on view detailed dashboard, that is where your Grafana come into the picture. You have to log in through admin. I can add a data source. Say if I want to add say HTTP Prometheus 1990, because the reason the service is running in the not as a local host but the Prometheus. So here I can give Prometheus dash. Okay, and rest of the things are going to be the same. So you have to type HTTP Prometheus 1990. Okay, all these instructions are written here under lab 4 projects GenAI chatbot. Okay, so don't get lost. Come back to this, and you should be able to run this. Okay, now if I say save and test, click on the dashboard, and if I re-import it, okay, because I re-imported it now, it basically what it does, in last 5 minutes it will give me all the script data. And the idea is, I should be able to monitor these AI models, Llama CPP, feature, like how it is, whether just like how you use Grafana to see your performance, to create a dashboard for your application. The same thing we can do it here also, but this time we are more focused on the AI model itself, right? So again, as I said, it is not a full fledged, but it shows you the integration, how the integration happens, right? And I should be able to know whether how these AI models are behaving, how my application is behaving against those AI models, right? But again, based on the time, I would say go ahead, try this, all the steps. You can see here, even I can go to the Prometheus here. So let me see if I can open the Prometheus. And if I type GPU, you can see here GenAI app model latency. You can see all those different metrics which Prometheus pick up, right? And based on that, say if I want to see, okay, Llama CPP prompt, it should be able to create some kind of a graph here based on the Llama model, right? But as I said, all these kind of GPU related stuff and the Gen AI related stuff, all the metrics, you can get it. Again, we can get into it, but yes, we have a lot of other stuff to cover. So I hope the demo works for you. But if not, just go through that particular page and you should be able to do it. Okay. Give me a thumbs up if you are able to understand what I am talking about. And if you feel like all these information are relevant and they are highly useful, it will help me in shaping up this particular workshop. So let's move ahead. So we covered models. Let's move to the tools, and this is where your MCP tool come into the picture. And then we'll at the last we'll talk about the code. Now MCP is nothing but an open framework which is introduced by Anthropic. It basically provides a context to the LLM. It's like a USB Type C port. The reason being, if you see today, even iPhone I can connect to the Type C. Even my Jetson Nano board, the NVIDIA Jetson Nano, I can convert to the Type C as a serial port. So Type C is used for the debugging. It is used for even charging your mobile, even sending the data from one mobile to another, right? So it is basically a Type C, right? It is more like a USB port which connects all those LLMs to your MCP server. And what it does, it provides the ability to provide the context to LLMs. If you can see, we have MCP clients. And when I say MCP client, it is nothing but, if you go back to our dashboard under the MCP toolkit, you can see the MCP clients here. The number of MCP clients here, we have a Cloud Code, Cloud Desktop, Codex, Continue. We have added bunch of them. Gemini CLI is one of the most popular. Like within a week time, it fetched around 70,000 GitHub stars just in a week time. Okay, so it's quite popular. We have a Goose, we have LM Studio, Open Code, Semaphore, Visual Studio Code is as well there, Jed is there, and yeah, Cloud Code. And I have written a couple of blogs around all of these different AI assistant. Especially we call it as an MCP client. So MCP client is more like your MCP, like more like the client, right? Which helps you to the AI assistant, where you just go ahead and start typing your prompt. And MCP server is something which is again running and in the form of containers. But most of the time you won't be able to see it because it runs inside an MCP gateway, because that is the component which is managing it. Okay, and then it can connects to the external APIs. The difficulties and challenges, if you see, the first difficulty here is, you might have seen here, if you go to this particular repo, awesome MCP server, you see there are more than 8,000 MCP servers. Okay, so discovery and distribution is the most difficult part today. I was trying out few of the MCP servers which have been built for GitHub. Now, in GitHub itself, there are like 5 to 6 MCP servers. Everyone is building their own MCP server, and if the tool name remains same, or they are same, then I would say, uh, uh, I would say, like say you build an MCP server with some kind of a tool name XYZ, and I build the same with the same name, then there is some kind of a contradiction which happens, right? Because now there are two models with the two MCP server with the same tool name. So you need to come up with those. Like when I was writing an horror story, I came across those kind of the recent one which I wrote is the WhatsApp MCP server, how the attack happened, and it was basically a tool poisoning. Okay, so we need to be very careful. So the first is discovery and distribution, because as I said, 8,000 MCP server, and still I'm scrolling this. Okay, and this is a repo. Just go to this repo and you will be able to see. um, the second one is installation and sandboxing, because now we are facing the same problem. Now say if you have 10 MCP server, which means that you have 10 different Python application running on your application, on your system. and say one of them contradicts, say if one of them requires 3.11, the other one 3.16, right? So there are chances that there can be a dependency here, right? And this is the same problem which we were facing around 11 years ago when we were when Docker was introduced, right? Today what we say, why don't you run this MCP server as a container, right, and solve a lot of your problem. So this is how the configuration look like, the MCP server on the cloud, in the cloud, where you require an npx. This is again a node.js. You need to have node.js installed on your machine, and then you have to know which package to use, even though it say like model context protocol slash server github, whether it is trustworthy or not, from where you picking up and all of this thing. And then again you are passing this token as a plain text also. So configuring this MCP client with server is like a 101. Say if I have 10 different MCP server, which means there are 10 101 connection which is happening. So every MCP client has 101 connection with an MCP server. This is how it look like, and this brings a runtime challenge because say one MCP server requires Node 12, the other one requires Python. So you need to take care of all those packages. And again, this is a problem which you are going to face. So discovery and distribution is one. We talked about the installation and sandbox. The third one is the credential management. Credential management means, take an example of this. This is a cloud desktop configuration where I'm running a GitHub MCP server, and you can see here that still we have to pass a credential here, right? Which needs to be defined in a static file, even though we are using container as MCP GitHub. But if you look at the GitHub access token we are passing as a plain text, which means that anyone who get access to your machine is going to get to know about all of this thing, because there is a very standard way of storing these configuration files somewhere. So the additional MCP challenges is that, as I said, right, each of these client launches their own servers, meaning a lot of containers and connection, and you will be trapped. The reason being, you need to manage all of them, and there are many containers which need credential. Again, credential problem will always be there. So we talked about all those difficulties. So how do we use this tool, especially MCP server, safely? And what Docker is trying to do here is we introduce a feature called as MCP catalog, which has collection of this is like a 2 months old slide where we had around 270. During the initial steps, we saw that we have more than 300 container as MCP server today. Okay, so you don't really have to worry about running all those Node.js or Python servers, Python instances locally, right? Which includes Stripe, GitHub, Elastic, and you can go to hub.docker.com, catalog MCP, and you can see all those MCP servers. Again, the MCP toolkit, as I said, right, when we say server, client, and catalog, this is basically, it comprises the MCP toolkit. And this will be useful for us when we are building the Agentic AI application. So toolkit is more like, what we say is, let's have a single MCP runtime in the form of the MCP gateway, which will manage all of these things. Rather than having 101 connection for those 10 different MCP server, now I have one single connection for all those MCP servers. Okay, so this is what we are talking about, and it solves a lot of our problem. First thing is standardized distribution, no more runtime setup, and security at work. But how do you manage this life cycle of containerized MCP server? And this is where your MCP gateway come into the picture, because anyway we have a single runtime, we have credential, and when we are building an agentic application, it becomes so crucial, right? We have one single component which can manage all of this thing, and this is an MCP gateway which can be run on the host machine as well as can be run inside a container. Now this is an example which shows you that it is running as a Docker Compose file, MCP gateway, where we are specifying the standard image Docker slash MCP gateway. You can use an API socket true and command where I can pass, say if I want to use a DuckDuckGo MCP server, I can just say ---- servers DuckDuckGo, and that should be able to give me all those information, right? We'll see it. So a typical agentic AI application which looks something like this now has one component which we introduce called as MCP gateway. And MCP gateway is more like just like a router, right? What is in the internet, or in your, say you are using a router. uh, Once you when you log into the router, you get to know which packages are flowing from which location, right? In the same way, now MCP gateway, right now we just acquired a company called as an MCP Defender. Okay, now that what it does, it basically scans it. Okay, scan all those MCP tools. So whenever the llama is providing, say LLM is want to access to the tools, then what will happen that all these agentic application will enable or provide this context to your to the MCP tools, right? Now this MCP gateway will try to be kind of, once this MCP defender is integrated, you will see that we can scan what is happening in the AI assistant itself. So in the Cloud desktop or Cloud Code or Gemini itself, I will get a notification saying like, what, these tool calls are happening. So which means that I can monitor. I will have a dashboard which will monitor the whole agentic AI flow. Okay. So MCP gateway is again used for the authentication, for secret management, tool analysis, filtering, and rate limiting. All of this intelligence we are trying to put it. You can. It is open source project. It has close to around 940 plus GitHub stars. It is getting popular. It is not too old. It just came around like 2 to 3 months back, and you should be able to see that there are a lot of things which we are trying to introduce here. So this is a very typical command to run MCP gateway, where we run it as a standard port 8811, use API socket, and then you can pass all those catalog. And these catalogs are nothing but an MCP catalog, which we are talking about. Say if you want to run your own MCP server, you don't have to pass those catalog options. Okay. Now this typical example, what it does, it goes to the MCP catalog or MCP servers which have been enabled, just like Firecrawl and Context 7 and all of this thing, Node.js, and it will pick up those MCP server and it will run behind it. That is the reason why you won't see this container running on your system when you run this agentic application, because it is being handled by MCP gateway itself. Okay. So what does it do? It orchestrate and manage the MCP server. It secures handling of API keys, one gateway endpoint, built-in logging, run in isolated Docker container. Say if you want to use Python client, right? So calling MCP gateway from Python would look something like this. You have one service which you specify as a client, build it. The environment which you pass is the gateway 9011. Again, you can specify your own. 8811 is a standard, but if you want to run on 9011, it's okay, you can run it. And the transport is streaming, because we can run it as a studio. They are remote MCP server, they are local MCP server which runs, right? So all those capabilities are integrated into it. One of the topic which I want to introduce, and this is really helpful, if you have read my MCP horror stories, if you search for MCP horror stories, you will see that there are 5 editions of MCP horror stories which I have written. I have been talking repeatedly about the interceptors even before LLM reach out to the tools, right? There is an interceptor in the form of a script, in the form of the container or HTTP. There are policies, just like how you put your firewall in your company, right? In the same way, there is an interceptor. Okay. Now, shell script interceptor, if you are passing in the form of script, it's a simple blocking rules. It does a quick security check, session management, rate limiting. The same way you can even run it inside a container. I can use an Alpine and use it as an interceptor. So whenever there is any kind of, say, in a chatbot, if you ask something, okay, and if I want to block then and there itself, I can do that. And I will show you quickly an example for that also. We have an HTTP service interceptor, which is again used for the enterprise. If you want to use, you can just say interceptor equals to before colon HTTP and then interceptor IP, and before and after. If you want to run some kind of a script, you can still do that. And this is again for all sort of this prompt injection and tool poisoning. You can always go ahead and use this example, okay, in the form of the script or in the form of the container, right? So we talked about tools. Let's talk about the code, and this is a time where we will be seeing, okay, how this application, we can build an agentic application. So we talked about models, how we specify. You can see here an example of Gemma 3 model, okay, where I need to pass an endpoint variable and a model variable. I have a tools which I have specified, with MCP gateway. You can see an example, and then we have a code. So in this example, if you see, the model is Gemma and the model name, and the name of the service is first citizen. It's basically, the model is the first citizen in Docker Compose. So the name is models, okay. And the tools are more like whatever you specify under the MCP gateway, because it is managing the life cycle of your tools. And then we have a code which could be in Python, Node.js, and that is where you are the dependencies on the models. So you just say models Gemma 3 and it start using it. Okay. So what we are going to do, Next, we are going to look at one specific example and see how we can combine all the three components and build an agentic AI application. Okay, so what I'm going to do now is I remember that one of the question was, what are the frameworks which you use? As I said, right, there was a Langsmith and all this thing. This is a slide which I wanted to present. So these Agentic Compose support all of these framework, and I can quickly show you here. If you go to github.com/docker compose for agents, okay, you will see here that there are list of classifications here. Okay, multi-agent and single agent system. Okay, you will see line graph here. Each of these has a compose file. We have an example of Spring AI, ADK, Minioness. We have a Creo AI, and the one which we are going to use is more like a Cerebrus. Okay, we are going to use a Cerebrus, which is very closer to your this ADK stuff, fact checker. Okay, but this is an open source repo. Okay, just go ahead and try this out. If maybe someone, if they can just go ahead and post this link. But the whole idea is that if you go to the workshop, right, and go to the Agentic Compose overview, you will see all those stuff, model tools, and the app code and all of the stuff. And you will see this particular link, right, coming again and again. Okay, so if you go to the projects and go, so let's pick up this particular example here. Okay, and see how it works. So uh, today we are going to implement this. Okay, now we are going to mix models, tools, and application code and try to build a kind of, let me see if there is any query or something. But let me post it here for you guys so that it becomes useful. So yeah, I just posted on the chat window directly so that you can always go back and look into it. So let's go through the architecture which we are going to build, and this will give you an idea about how these agentic AI application look like. So you have a user interface. DevDuck orchestrator is like a project manager. Okay, say project manager has what he does. He assigns, he coordinate, ensuring that your project is completed on time. Right. I have a local agent who is very similar to like 5 years of experience in Node.js. Okay, and then I have a Cerebrus agent who has 15 years of experience. Even though I don't know whether how many years in Node.js, how old is Node.js, but the idea is this particular guy is a cloud hosted API. The Cerebrus is a cloud hosting company, and what they do, they host the models. Okay, just like Docker Hub, we host images and models. They also host these models, and these Cerebrus models will have a capability of MCP tools. And that MCP tool is, again, there are two MCP servers here, Context 7 and Node Sandbox MCP server. And as I said, the component which we are going to use in MCP gateway. Okay, what does this Context 7 does? It basically a framework documentation. It will fetch me all the latest and greatest stuff which is happening in Express.js or Angular. And the Node Sandbox execution is more like it is running a container for you. It is testing it, and then it giving you the result. So two MCP server, one MCP gateway, two models. One is local, running on our local machine, which is uses a Jan Nano or Lucy. The other one is a Cerebrus, which uses Llama but on the cloud. So what do you think, how much time it would take to implement all of this thing if you want to implement without using a Docker container? Can you put it in the chat window? What do you think, based on the complexity, how long will it take to implement this whole architecture? Let's wait for you guys. I could see that there are a couple of questions, but keep the question, just provide a feedback saying like, okay, whether you are able to follow up all this thing or not. I know like there are few topics which are simple, the few topics are really complicated. But as I said, once you do a hands-on, you will get to know. And when we are performing this demo, you will see that how easy it is to bring up this agentic AI application. But go ahead, put it in the chat window saying like you are able to, how long you are able to implement the whole architecture, where you have a MCP gateway, you have a Context 7 Node Sandbox. Someone posted like 2 to 3 weeks. Okay, there is nothing wrong on that. If you are not using container, definitely you are going to take that time. uh, the reason being, these agentic application has to be written in terms of like before even going to the compose file, right? But yes, let's jump directly into a kind of the implementation. First, we'll just go ahead and run it, and then later point of time, we'll see. We'll talk about the different component altogether. Okay. So what I'm going to do here is I will bring down this compose file which I was running initially, and so the repo is Docker Cerebrus demo. Okay. So let me pick up. Okay, let me show you what shall we do. Okay, if you go to uh, Agentic Compose, under that there is a project. The first project is dev.go. This is an overview which we talked about. Okay, we have an agent roles which is dev.duck orchestrator, local agent, Cerebrus, and MCP gateway. How it works, you can go through each one of them. This is the user flow. Say if I write any kind of a prompt, how it is going to go through the agents, right? Which are the components which are coming with the picture, MCP gateway, context 7, and all of this thing. um, and then if you go to getting started, okay, this is where all the steps are there. You have to clone this repo. Okay, and the repo is there, docker samples docker hyphen cerebrus hyphen demo. This is where you have to clone the cerebrus demo repository, and then we will going to execute agentic compose this time. Within few seconds you will be able to see that the whole application will come up, okay, just with one single compose file which has MCP, which has LLM, all those components in place. Okay, so but before that there are some environmental variables which we need to specify. So the first thing you need to do is go to the Cerebrus AI, click on get started. Okay, you just register through your Google account, and then on the left hand side you see all those API keys. Okay, generate those API key. You can just, I can copy this API key. Okay, and then I can just put it in my environmental variable file. Okay, so the environmental variable is more like, I will show you quickly. This is my VS code. I have .env file, and I have specified this API key, as well as Cerebrus API key, the base URL, and chat model. Okay, these three things. Now you might be thinking about what this chat model is all about. Now if you go back to Cerebrus, okay, if you go to the playground, on the top you will see all these models which are available. Okay, we have a llama 3.3, coin 3, 235b instruct. So I picked up one of these instruct because I need one model which is very good in reasoning, taking up all those complex stuff, and the local model which I am going to use for very simple stuff. Okay, so you understood what you need to do. Go to the Cerebrus, click on get started. Okay, go to the API key, pick this API key, and the other thing is pick up one of this model. I would suggest pick up this instruct model which is in the third one, right? And these two entries should be under your .env file here. Okay, now I am going to, okay, so I will be going to Docker Cerebrus demo, and this is how my compose file look like. Let me show you. So the first one is a project manager, okay, which is a dev agent. He's a project manager, he's an orchestrator. I have specified .env file, so it is going to pick up all this. I have specified two of the models. One is Jan Nano and Lucy. Okay, both of these models I have specified it here. The port it runs on 8000. The MCP gateway runs on MCP-gateway 8811. And now each of these agents comes with some kind of a instructions, right? So what I have done here is more like, DevDuck is like, you are a DevDuck, you are a programming expert designed to coordinate Node.js expert. Okay, so which means that I'm a project manager and I should deal with those Node.js or Python developers, right, in the same way. So local agent can, okay, I'm specifying that there are two agents here, local agents as well as the cloud API agent, which is Cerebrus agent. Local agent can help you in reading and understanding. It's more like a reasoning part. The Cerebrus has access to the tools. He can even do the action. He doesn't only just answer your question, but he will do the actions also. Now local agent, it is just like, you are forming a new team and you are introducing the whole team. The first project manager introduced himself. Now the local agent is introducing, saying like, what, I am highly useful agent for general development tasks. I am all your answered must start with local agent speaking. So whenever I switch from one agent to another, you will see that he answer all of this stuff. Then we have a Cerebrus agent. Now Cerebrus agent is like an expert guy who has 15 to 20 years of experience, right? And he's a Node.js programming expert. Again, he depends upon, this service depends on MCP gateway. This is how the MCP gateway look like. Now this is an MCP gateway where we will specify both MCP server with just one entry, okay, which is -FN server context 7 and node code sandbox. The name should be correct, okay. I can even specify the tools, like those kind of a granular settings I can do it, okay. And then rest of the models which is going to pick up at this point of time, I'm just using GenAI or Lucy, okay. We are not using Mistral and Llama 3 at this point of time. So this is a specification. If you look at the agents, how we specify, so we have a data agents, and if you go to the agent.py, so if you see here, as we are using ADK, which is the agent development toolkit, which is again from the Google, and Google by default supports Gemini. If you want to use other model, then we need to use a light LLM wrapper. So that is the reason why you see we are importing this light LLM, okay. And rest of the things are like, agent name, everything which it is picking up from, the environmental variable. This is a main.py where we are specifying, okay, because it uses a fast API. So that is what, the whole specification. We have few of the Docker files here which we have specified for our application. If you are using offload, I have a specific Docker Compose file, because when you are in offload means you are into the cloud. So how does it going to run? Okay. And as I said, right, each of these model has to be run inside a container. So we need to go ahead and make those changes in MCP gateway also. So if you see here, I'm running an MCP gateway, but at the same time, there is some kind of a customization which has to be done. So I won't suggest to use offload at this point of time, because it is outside the scope. But let's go ahead and try to bring up this particular compose file. So if I say same Docker compose, and I will pass -FN bit, okay. Now when I use this command, right, it will bring up my MCP gateway. It will bring up all those, the both LLMs, okay. And now you can see here that my agent development toolkit runs in port 8000, okay. So let's go ahead and browse through 8000, and you see I have an agent development kit with the name dev. Okay. Now I will start with saying like, okay, hello, and let's see what happens. I will enable the token streaming so that you can see how the whole architecture would look like what is the message which is flowing. Now, as I said, right, under a Docker Compose, if you remember, we are specified that whenever we start any discussion, it first goes to the project manager. So is the dev duck speaking? How can I assist you? How many agents are running in this system? So I'm specifying, I'm asking my project manager that how many employees you have, how many experts you have. And this guy says, you know what, I have two experts here, okay. Currently there are two agents, Cerebrus agent and the local agent. And I say like, okay, can I speak to local agent? Let's see what happens here, okay. Can I speak to local agent? And now this is a time where you will see that, you can open the response right in the way. So DevDuck agent is a project manager. We have a Cerebrus and local agent. Okay. Now the transfer is happening to the local agent so that I can talk to him. And these are basically the capabilities which these agents comes with. Okay. Now if I click on this response, I can see that right now it's a local agent which is running. Okay. Okay. Can you write a to-do list application for me? It's a very simple request which I'm putting it. Okay. It's not complex. And this guy is like, I can help you out. Do you want to know React? Can you build it using React and Node.js or something like that? And this guy, what it will do, I can help you build it. Start writing it down. And trust me, this is something which is happening locally. Okay. Let me outline the step. Let's start by setting the beginning. Let me provide the code for this. And I say yes. And it provides you with the overall code. Okay. It transferring to the agents. Setting the, now when I say code, that could be something which I might be like, it's very generic, right? So it could be on the cloud, it could be on the local machine, right? So what it does, based on the capability, it basically switched to Cerebrus, because right now Cerebrus has all this information about, okay, what is the latest version of Node.js, what is the latest version of React, which we have, right? Based on that, it started picking up the documentation part of it. And now, right now, what is happening that even if I open containers, right, you can see here, it has spin up the container also. So you can see here, it has spin up the container also now, because when I say to-do list application, it is trying to go ahead and deploy this application also. Okay, again, it depends upon the prompt, is what I can say. But at the same time, you will see here that, the both applications are up and running, correct? And going back to my, so it is, if you see here, it is even going ahead and writing and bringing up the sandbox, which means that now within few seconds I will have a to-do list application up and running on my machine. Even though I was not expecting that, because again, the problem with LLM is that it doesn't have a code boundaries and all together, right? It will just like, you might have used Lovable, like you just go and provide a prompt and then you see 1500 lines of code, right? The same thing is happening here. And if I click on any one of them, you can see here right now the Cerebrus agent has come into the picture and it is trying to execute it. Okay, this is basically a real, the real world example of how these agentic AI application look like. Now, did you like this particular demo? If yes, just go to the chat window and say yes. But if you see like, okay, it can be improved or there could be more exciting stuff, I'm happy to listen to that. Maybe post on in the Slack channel, because I also created a new Slack channel called MCP workshop, where you can put your thoughts. But the whole idea is that I don't really have to set up, go to the chat GPT, ask any question, copy those code, put it right here. Now, using this agentic application locally, I can always go back and try to execute and bring up those instances. Right now you can see here that these containers, right? If you see here, these containers, which is in the sandbox, has come up, right? My Docker Cerebrus, the MCP gateway, they are both of the services are running, right? My DevDuck agent is running. My MCP gateway is coming into the picture. So if you see here, there is some kind of a tool calling which is happening internally. But the whole idea is, it is trying to deploy this application. Okay, so what I can do, I can go back and let's see if I can refresh this. Okay, and I say, hello, can I talk to local agent? Okay, can I talk to Cerebrus? Okay, now I'm switching from one agent to another, right? And you can see here the Cerebrus is speaking. Now let me go back and pick up a very interesting flow altogether. Say if I'm saying, okay, search a documentation for express routing. Okay, let's try this. Let's see what happens. Now when I say search documentation, what is happening now? It will go ahead and pick up the context 7 MCP server. The reason being that has the requirement tools, and based on that, it give me the all the results. Now, if I click on this particular example, this is true that it goes to the get library docs and then to the resolve library ID. Right now, let's pick up the other example, saying like, okay, can you create a function that adds two numbers and test it in the sandbox? Okay. Now, if you go to the container here, so what I'm going to do here is I will delete this sandbox which it has already created, and there is some kind of a dev container JavaScript because it is trying to deploy all those stuff. So I'm just going to go ahead and clean this up. Okay, I'm going to clean this up. Right now there is no container running on my machine, and what I'm going to do now is go to my agent and I say, okay, create a function that adds two number and test it in the sandbox. Now, my local agent can take care of this stuff, adding a two numbers, okay, because it is not a complex application. But testing it in the sandbox is something which is understand that, okay, I need to go ahead and pick up this MCP server because the context is right there. Okay, so MCP tools right now, my cloud API has that kind of a capability of bringing up this MCP tool, not my local agent. Okay, if I have to do it, I have to make the changes. Now, when I said that does model runner has capability of MCP tooling, yes, but you need to pick up the right one. Like Coin model is the one, Coin 3 model. Again, it is like a more than 10 GB size. You have to pick up those models and try to run it. But let's run this and see what happens here. Okay, so I said, can you go ahead, create a function and all of this thing. Okay, so in some way what it does, it basically, let's see, the client is closed. Okay, hang me. Let me see if I have to reopen this. Let me do it again and try to see if the application is comes up. So let me go back to my Docker desktop, ensuring that, okay, I think we stopped one of the service. That could be one of the reason. Can I, so if I say create a sandbox, two numbers and test in sandbox, okay. So let's see whether it automatically picks up those, the environment is a dev duck. So what it does, let me know if you need to run this in the sandbox. So your dev duck or a local agent was capable of answering you to this, but when the moment I say yes, that's where your sandbox will come into the picture. Okay, let's see what it does. Yeah, so if you see here, DevDuck speaking, you're welcome. The function, let me know if you'd like to extend this function, test in different. Okay, I will say, can I speak to Cerebrus agent? Okay, it is transferring, and now Cerebrus come into the picture. Let me go back and now try this stuff, the last thing which we want to try. And it looks like the model which it is getting close. The reason being, we abruptly stopped one of the service. That is the reason. But the whole idea is that, as we have seen, it should create a node.js container here, and it should be able to implement it. Okay, so this is one of the use case where I wanted to show you like how these agents come into the picture and they run it. Okay, now there are few of the example, like we have around like 15 more minutes, so I want to show you few of the example. So if you are finding it really interesting, and if you want to see more demos for next 15 to 20 minutes, just say yes in the chat window and I should be able to help you out. Again, thanks a lot for being there for so long time. Definitely I feel like you might have got what we are talking about, and these are the things happening in this space, right? So when anyone says agentic AI, MCP, this is what they mean, right? When you combine all those model tools and all of this thing into a kind of a single Docker Compose file. So give a thumbs up if you are finding it really useful, so that I can move ahead and show you a couple of more demos, right? Yes, I see Shantanu. He said yes. How about the other folks? Are you guys finding it useful? Okay, so let me show you a more exciting examples. Okay, so if you go to so what I'm going to do, I'm going to go back, bring this down, so I don't want to disturb the whole setup altogether. And one of the example which I want to show you is the product catalog example. Okay, and I will show you like how those interceptor come into the picture. Okay, now if you go back here and look at the model runner projects, there is a product catalog chatbot. Okay, so what we are going to do, let's build a chatbot for the product catalog. Okay, and later point of time I will show you that how you can bring intercept into the action, and how you can prevent those tool poisoning or some kind of tool poisoning and the prompt injection kind of stuff, right? So under lab 4, the catalog chatbot, you will see that this is the architecture we are trying to build. We have a front end, we have agent portal, chatbot UI. But quickly, let me go ahead and so we are going to use the same Llama 3.2. I am going to clone this repo here. Let me do this and see if it is, so I am cloning. Okay, it has already been downloaded. So let me pick this up. So the project, the repo is catalog service node chatbot. Okay, even if you are not interested to type, it's okay. But what I want to show you here is I have a Docker Compose file somewhere. Let me see. This is my Compose file, and we are building a product catalog system which has all those great components. So say I have an MCP gateway, model runner, chatbot API, agent services. I have Postgres, Mongo, Kafka. Like it is like a complex product catalog service. Okay, which has front end, back end, database, and everything. Okay. Now what I'm going to do, I have this service called as backend. Okay, it uses all those Postgres. We have a front end. I have an agent portal, right? And agent service. I'm using Llama we have an MCP gateway, I have a chatbot backend, right? And then I'm using Kafka, all those configuration of the Kafka network, Postgres, pgadmin, Mongo, Wiremock, and I'm using models like a Llama 3.2. So which means that I have around close to around 15 different components. Okay. And now I'm thinking more of moving from development to production altogether. But at the same time, what I'm going to do is say Docker Compose up -d. That's it. So this will bring the model. It will bring all the services: Postgres, Kafka, Mongo, Wiremock, pgadmin, Kafka UI, all those event streaming and all this thing, agent portal, chatbot. And the final result which you are going to see is more like, I'm talking about product catalog system. Whenever someone adds a new product, how it is going to behave, and how the I'm building a chatbot for my own product catalog system. Like in most of the cases, what we do, we deploy this for the product catalog. You add the product and it gets listed, right? In my case, what I'm doing here is more like, building up something from scratch, and this is going to be a chatbot. Okay, so if you see here the catalog service, you see close to around 15 to 15 and more. Okay, now when I open this, okay, so let's see, 5174. So I have a product catalog assistant. There are 34 product at this point of time. So what I have done here initially, I have a script which basically add those products, which is like sh add products. And now you will see that all these products get added just for a demo purpose. And once it is added, I can always go ahead and say that, okay, Docker Compose up IFND, and now you will see here the more products we added. We have 68 product. I run it twice. Now I have a chatbot for my product catalog. You can have some kind of an application running on your local machine, right? Show me all the electronics device. When I say this is again a Gen 1.0 kind of a stuff. Um, it says that basic search. Okay, let me see if I say hello, what happens here. Okay, I have a specific product. Which category do you have? Let's see if it works, because it takes time to models to load. So you can see here you have 6 categories in your catalog. Okay, show me, find products under $50. Okay, again, this repo is a public repo. You can always go ahead, use this repo, and you can see here it is listing all those files. Okay, now this was more about how you deploy a product catalog. And this is the chatbot interface in 5174. We have a main front end in 5173. We have a Kafka UI, pgadmin, and the chatbot capabilities would be, okay, show me all the electronics under $500. So it's a very simple example. Okay, now let's take this, keep on Agentic Compose and Agentic product catalog. We will try to implement agents in this. Okay, and what these agents are going to do, I will show you. Very similar kind of an architecture, but this time we are specifying the MCP gateway. Okay, and we are going to use Llama 3.2, and then okay, the chatbot compose of hyphen build interface, agent portal, and Kafka UI. Okay, let me see what happens here. I really need to check whether this is the same 5173 or something like that. Okay, now what has happened that till now what we have seen, whenever you add a product, right, it is just getting added. So imagine you are a Flipkart or Amazon, right, and you have a software where people just go ahead and add it. But I want to check initial phase itself that the details which have been added are authentic or not. Say if I'm submitting a product for AI evaluation. So for example, the vendor name is, say, NVIDIA, category is electronics. Okay, product name is NVIDIA Jetson EGX Thor. Okay, product description is so you can say like 128 GB RAM. This could be one to say. You can build humanoid robot. Okay, the price, I would say, let's keep it as $4,000. Submit for evaluation. Now what it does, it basically does an AI analyzer. Okay, AI analyzer come into the picture. Now I can quickly get into MCP gateway here, and you can see here that in the MongoDB itself, you can see here that there are few of the models which it should show. Okay, let me see what is the output here. Okay, let me go back and see if it has all the latest stuff which we require, the front end Kafka. Okay, let me look into this. Okay, so anyway, going back to this, you see here, based on the name, the price, what it does, it basically does evaluation is based on the market study that this NVIDIA Thor is a right product to add. Okay, it has the right information, and based on that it gives you a point saying like 85/100 is like an approved, the threshold is 70. So NVIDIA AGX Thor offers exceptional 128 GB RAM capabilities. So it basically did kind of an evaluation, and based on that it added it. Now let's submit another product, which is Evil. The vendor name is Evil. Category is hacking. Product name is Evil Evil Nano. Okay. This is used for hacking. Okay. So I would say like, okay, this is used for and showcase. Okay. And I say price, I will say $9. Okay. Now I added a product which is starting with Evil. Okay. There is what it will do, it will basically verify whether these product exist or not. So this will be more like a marketing agent come into the picture, and it will try to find out. Then we have a review agent which comes to the picture, which basically finds out whether the review is correct or not, right? When I submit this product, okay, so oh my god, this is not expected, but the whole idea is, it should not show that this particular product should enable it. The reason being, if you see here, it is I think the problem is when I see all those logs here, it is not even reaching out back to the Mongo, and those agents are coming to the picture. But the whole idea is that your your agentic system should not allow such kind of authentication, and this is where your interceptor come into the picture. Let me see what has happened in the backend, so I can get into, I would say, compose.yaml file, and let's see what is happening here. Okay, maybe I need to pick up the right stuff here in terms of interceptor. Oh, we don't have an interceptor here. The MCP gateway interceptor should be there. I think I picked up the other repo itself. But the whole idea is that whenever we specify the MCP gateway, there has to be an interceptor which come into the picture. So maybe I was pointing to the wrong repo altogether. Example would be something which I can show you here. If you go to Ajit Rena / not pen port buzz, it will be more like a pen shop store. Yeah, pen shop demo. Quickly I can show you that. And if you see here the interceptors here, actually we picked up the wrong one. There are like a data protector and price guard. So what happens that in a Docker compose file, okay, there will be a couple of interceptor which you can specify here. Okay, so you can see here the interceptor. In our other example which we picked up, we didn't have an interceptor here, so we need to have such kind of an entry. Maybe in the chat window I'll put the right project, but it looks like there are two things which I was trying to combine here. But the whole idea is, when you specify the MCP gateway, you need to pass this interceptor which act as a kind of a guardrails. Okay, this is basically the guardrails everyone is talking about, right? These are the interceptor where before you add any of the product, this script will come into the picture. This is a shell script based interceptor. So this script come into the picture and you can intercept it. But again, this topic was not as part of our, the demo was not part of our showcase, but the whole idea is that we can get into that, the DevDuck orchestrator, right? When you specify some kind of a prompt, it can just go ahead and, ensure that those interceptor come into the picture. Now, looking at the time, I think we are at the right time. And yes, there are a few of the slides which I don't want to go through it. Upload, if you really want to try upload, I can show you quickly how it happens. So go to the dashboard here, and if the moment I click upload, since right now it is disabled for me, I should be able to switch to the upload right here by clicking on this. Okay, but as I said, right, we are not going to cover that. And yeah, we have Docker upload start, status, stop, all those comments. And thank you so much for being with me. I think there are a lot of topics which we can discuss. Offload is the one. Interceptor, maybe in the next session I can show you the right repo. I think we picked up the wrong one. But tell me in the chat, how do you feel? Was it really useful? And based on that, we can always go back and try to see, like in the future, if you want me to cover all those topics, I am happy to cover on that. There are few of the links which I have added here. There is a blog on Cerebrus, Docker Compose, Secure AI coding. You can go through it. We have a Docker DevDuck Vercel.app. It's a full-fledged only on the DevDuck side of it. We have an MCP gateway. Again, all of these are like public repo. You don't need any kind of a permission. You can just go ahead and access it. So I hope this was useful. I enjoyed delivering this. I hope you have, a couple of these kind of, new terms which you have learned today. And just to highlight that, um, for those who came as a reference, I would say, like, we have a meetup.com collabnix website, which has close to around 10,000 plus members. You can always visit it. And you have, like, this is the one. There is another event which is coming up called as an Agentic and GenAI community meetup in collaboration Neo4j, which is happening on November 22nd. But as I said, right, starting 2026, we are going to have a more and more virtual event. And yeah, I can definitely share this link right here, the meetup link. And if you really want to try the benches, you can always go ahead and try this out. I hope it was useful, but feel free to provide me with the feedback right in the chat window, so that I can take down all those notes and plan with the community. So I don't want me to always coming as an alone, but next time you will see, like, one of the community members who is expert in this field coming up. He will be delivering the talk. So right now, I will open the floor for Q&A. If you have any question, just put it in the chat window, and I should be able to answer those questions. Go ahead and put it in the chat window. Thanks, Shantanu. I'm glad that you found this really insightful. We'll bring more and more such kind of a session in the near future. Any questions which you have in your mind, which you want me to cover in the next session? Definitely, I can include it. And I want you to be, if you are in Bangalore, feel free to connect with us for our community event, which we do almost every month. So you get a lot of opportunity to collaborate, talk to the experts. And as I said, right, I want to keep it as more like a community focus. So next time you will see, like, I will be inviting few of the guests who can come, who can present. So we'll make it more interactive. Sharavana, thank you so much again. I know you have been quite active in this community, but yes, thanks for joining us today, even on Saturday. And this is the first time, this year we are doing any kind of a virtual session. So there's a lot of learning, a lot of topics to be included, but at the same time, sharing is caring, right? Okay. Is Aman, you say, like, I would love to see scaled down version of what was showcased today. Okay. Yeah, definitely we can look into it. um, Amit Raj, okay, you are from Bangalore, so definitely you can always come to our meetup. You can go to the meetup.com/collabnix, and you should be able to see or enroll. And most of these events which we do, almost all, are free. And these happens on mostly on Saturdays, so you can always uh, reach out. Shantanu, will it be available for offline practical implementation of the useful? Yes, these are hosted, right? We are not going to like whatever I talked is more like an open source. Even Docker desktop which you are downloading is open source. Whatever the demo, practical implication, these are things which I've been talking more and more in the meetup. So everything is free of cost. It's not like you have to even register for this. Right? You just go ahead and access it. I suggest you all to do this, try this hands-on in your system whenever you are free. You will feel like you will get confidence on what this agentic AI, because there are a lot of noise around it, right? So that's the reason. Yes, I can share the meetup location. It is right there on the meetup page. You can find all of them. But as I said, right, we do have a Slack channel. If you want to join with us and get all this information, where say you are stuck somewhere, right? And our Slack channel has more than 10,000 people. So I'm sure like whenever we have time, people just chime in and they start responding. Okay. I think with this, we are like 5 minutes ahead of the time. But thank you so much for being with us, each one of you. There's a lot of good comments coming in. I will go through it, and if you really like it, just give a thumbs up, put any comment on the Slack channel. And as I said, right, these presentation will be there, which is available. So even if we want to edit something, we can always go ahead, but I don't think it is required. It will be there. So thank you again for your time and have a great weekend. Okay, see you guys.